In some advanced situations, creating the implementation type for a service may require some manual intervention. This demo will show how to register services that provide an implementation factory. We'll also discuss some of the scenarios where it may be necessary to use them. Implementation factories offer complete control over how instances of an implementation type are created. When adding a registration that uses an implementation factory, we provide a delegate that gets called when resolving the service. The delegate for an implementation factory is a simple func. The func delegate must accept a single iService provider parameter. When the delegate is invoked at runtime, the service provider will have been built, and therefore inside our delegate we have access to the service provider in order to resolve services. This delegate is responsible for creating an instance of the generic tService service type. The first example we'll look at is forwarding a registration of a service type onto an existing registration. I've seen a common preference with developers working on ASP.NET Core applications to allow access to configuration values without taking a direct dependency on iOptions of T. Here's the booking configuration class that we used earlier. Let's update our code to support injecting this directly via an interface to any dependent classes. First, we'll extract an interface for this booking configuration. I'll accept the defaults for this new type and its members. We will return to the program file to add a singleton registration into the dependency injection container for this new service. We'll apply forwarding by providing an implementation factory that returns an existing object from the dependency injection container. Here's the registration for the booking configuration that we're going to be returning from this factory method. To begin the registration, we only need to provide a single generic argument that defines the service type for this registration. In this case, it's our iBooking configuration interface. We can then use an overload of the try_add_singleton method that accepts an implementation factory as its argument. Remember, this is a simple func delegate that returns an instance of the service type for the registration. We can use a simple lambda expression that uses the service provider to resolve the iOptions of booking configuration from the service provider. To resolve that iOptions instance, we'll call the getRequiredService method on the iService provider. This method either returns our required service or it throws an exception if it's not available from the container at runtime. After resolving the iOptions instance, we can return its value property as the instance resolved for this service type. This will be the bound booking configuration, which implements our new interface. Using this technique, we've created an additional registration that forwards a request for our new service type to an existing service resolved from the dependency injection container. We can update the max booking length rule to use this new interface as its constructor parameter. This simplifies the code required inside the constructor, as we now have direct access to an instance of iBooking configuration that we can directly store into our private field. The remaining code is unchanged. By debugging the application, we can verify that the booking page continues to function as it did before, with the configuration now accessible via our new interface. Another situation where an implementation factory registration can be helpful is when we need to resolve an implementation that the service provider cannot automatically construct. Inside the application, we have a class called membershipAdvert. This class accepts some primitive types required in its constructor. As we learned early on in this course, this makes it a poor candidate for dependency injection. The application also provides a memberAdvertBuilder type, which is intended to assist in the creation of the membership advert. This builder accepts some membership configuration to create the final membership advert instance. For this demo, let's pretend that this is legacy code provided by a third-party library. We can't go and change the existing types, but we can work with them to register them into the container. Returning to the program class, we can first register the membership configuration and bind it to the correct configuration section. Next, we'll register the membership advert builder as a transient service. We must use the transient lifetime when registering the builder because it contains mutable state. The transient lifetime ensures that we get a unique instance of the builder every time it's being resolved, and this ensures thread safety should other types also depend on this builder. We can add a second registration to handle the iMembership advert service type. We'll be using an implementation factory. The lifetime for this service can be singleton because the implementation of membership advert is immutable and therefore thread safe. The membership advert instance will be created once when it's first needed and can be reused across subsequent requests. Inside the delegate, we'll resolve the iMembership advert builder from the service provider. This service is transient, so we always get a fresh instance. We can apply a discount and build the final advert instance using this builder. This will be the advert that we then return as the implementation for the iMembership advert service type. Although we're relying on a transient service within the factory code in order to create the membership advert, this is acceptable. We're only using the builder instance to create the membership advert. The builder is not captured by the membership advert type, and it will be released after this factory method returns. I'll add a breakpoint that we'll need in a moment. Before running the application, we should accept an iMembership advert in the constructor of the index model. I'll store the injected advert into a property on the model. In the view, I'll paste in some pre-prepared code that will display the advert if it's available on the model. After we start debugging, the breakpoint is hit inside the implementation factory delegate. A new advert has been built using the builder. If I continue debugging, the homepage now loads and the new membership advert is rendered. Consider the use of implementation factories as a more advanced scenario that you should rarely need to apply. The first choice in these situations should be to review whether your code can be refactored to support automatic creation of the objects by the container. But this might not always be possible when you're working with legacy or third-party code. And in these situations, you may want to add types to the container where you have no direct control over their creation, and an implementation factory can provide the control that you need to support this. This demo will explain why it can sometimes be necessary to register the same implementation type for multiple service types. We'll look at a few potential techniques for achieving such registrations. Inside the tennis booking application, a service exists that provides a random greeting message to visitors. The greeting is provided by a greeting service, which implements an iHomepage greeting service interface. This service loads a collection of greetings from a file when the service is constructed and stores them into memory. Let's begin by adding a greeting to the application's homepage. Inside the index model, we can accept the iHomepage greeting service via the constructor and store that into a private field. Further down in the existing code, we have a static greeting message that we'll replace. We can use the injected greeting service and call the getRandomHomepage greeting method. We then need to enable the showGreeting property by setting its value to true in order for this to appear on the homepage. We will of course need to register this greeting with the container inside the program file. This is a good candidate for a singleton lifetime as it contains no mutable state, and constructing an instance of it is relatively expensive because it needs to read data from a JSON file. After registering this, we can debug the application and a new greeting is shown on the homepage. Imagine sometime later in our development of this application, we receive a new requirement to add a random greeting for logged in members with a personalized message when they access their bookings. The plan is to extend the greeting service to support both types of greeting. Rather than change the existing interface, a new iLoggedIn user greeting service interface has been defined. It includes a single method that takes the user's name and returns a user greeting for them. The existing greeting service does most of what we need already, so we'll add the new interface to it and implement it. Inside the method implementation, we can access a random greeting from the login greetings collection. These greetings have a basic template that allows for inserting the user's name into the final greeting. With this complete, we'll accept this new interface as a dependency of the bookings model and again store the injected instance into a field. We can then use it to set the greeting property with a value. we can register this service type in the program class. A tempting option is to add an additional service registration for the new service type with an implementation type of greeting service. I'll demonstrate why this is a problem by setting a breakpoint in the greeting service constructor and then running the application. As the application loads the home page, the greeting service constructor breakpoint is hit. The heavy work of loading the greetings file and parsing the JSON now begins. I'll hit F5 to continue, and the home page finishes loading. We can refresh the home page a few times, which results in a fresh greeting, but the greeting service constructor is not called again because the service is registered as singleton. This is the behavior we expect and desire here. If I navigate to the bookings page, the breakpoint inside the greeting service constructor is hit again, which might be surprising. Why did this get called again when the service is registered as a singleton? Let's look at the registration code to really understand the problem. Because we've created two registrations, one for each interface, when each service type is resolved, its own greeting service instance is created to act as the implementation type. Each of these instances has a singleton lifetime, but they are unique per service type. In some situations, this might be acceptable, but because our greeting service loads data into memory when constructed, creating two instances doubles the memory requirement. We want to ensure that the same singleton instance gets resolved for both interfaces, and there are two ways we can tackle this. The first option is to use an overload of the try_add_singleton method that accepts passing an existing instance of an object as an argument. In the configure services method, we can create an instance of the greeting service. The greeting service constructor has a single parameter requiring an iHosting environment to be provided. Fortunately, this is a fundamental service in ASP.NET Core, and by this point in the code, it's already available on the Web Application Builder. Now that we have an instance of a greeting service, we can pass this into both of our registrations to return the same instance when they're resolved from the container. The try_add_singleton method includes an overload that accepts a pre-instantiated instance that satisfies the service type. And we can use the same instance for both registrations. If I rerun the application, we can check the effect of making this change. The greeting service constructor is hit because we created a new instance inside the program file. After pressing F5, the home page loads and I can navigate to the bookings page. This time it loads without the greeting service constructor being called a second time. There is now a single instance of the greeting service when the application runs, regardless of which interface is being used to resolve it from the container. A downside of this approach is that I'm now responsible for creating that instance of the greeting service. Also, remember what we learned earlier. Any instances created in this way outside of the container will not be disposed of by the container should they implement the iDisposable interface. Do you think there's anything we could do here to improve our service registrations? The answer is yes. We could make use of implementation factories. First, we'll create a singleton registration for the greeting service so that we can later access it from the service provider. We'll update the service registrations for each interface to provide a simple implementation factory delegate to forward to the greeting service instance. Because the container is now responsible for creating the greeting service, any dependencies it requires, such as the iHosting environment parameter, can now be injected by the service provider at runtime. With this change, the container owns the creation of the instance and, if necessary, could dispose of it correctly. We can repeat our steps to test the behavior by running the application a final time. The greeting service constructor is still only hit once, the first time it's resolved from the service provider, and after that, the same singleton instance is resolved for both interfaces that it implements.